Okay, my name's Hubert Ward, and today I'm going to try and go through something called partial fractions. I always like to justify why we go jumping through these hoops, and believe you me, this is quite a hoop to jump through. But later on in the course, we're going to start looking at integration. Some of you may already have done integration, and here is an example of an integral. I equals the integration between 0 and 6 of 8x minus 7 over x plus 1 times x minus 2 with respect to x. Now, of course, normal integration, you just basically make it fit the standard tables. And unfortunately, this expression will never fit the standard tables. So we don't give up. What we do is manipulate the expression. So we're going to manipulate that fraction, because that's what it is. It's got a numerator and a denominator. It's called a compound fraction. So what we're going to do is we're going to manipulate that compound fraction and split it up into its partial fractions, and then see if that will leave integration. And of course it will. I mean, I'm not going to do the integration in this lesson, but I'm going to show you how we actually tackle this problem. Here is an expression that doesn't fit the standard integration. So what we have to do is manipulate it. In other words, take the compound fraction and split it into its partial fractions. Now, as you'll see later, the partial fractions have some standard forms of their own. I'm trying to show you some here. Right, so there's basically three that we deal with, although I don't really bother too much with the third one. Okay, you'll see later on how we deal with that quadratic in the third one. But we've got a function of x over x plus a times x plus b equates to a over x plus a plus b over x plus b. Now that's actually the one that's in our integration above. We've also got a function of x over x plus a squared, which is repeated roots to some extent. Well, that equates to a over x plus a plus b over x plus a squared. And of course the final one, the quadratic with a fourth term, a third term, x plus d. Again, there's the standard form that they split into. It looked confusing to begin with, but as we go through the process, I think you'll find that it's fairly straightforward. So what I'm going to do then, I'm going to tackle that compound fraction in that integration and split up into its partial fractions here. So let's get on with any more ado. So reduce the following compound fraction into its parts. Eight x minus 7 divided by, let's just have a quick check, remind myself, my memory is going 8x minus 7, x plus 1 over x minus 2. So x plus 1 times x minus 2. Now that is equivalent to, right, because we don't know what it equals yet, but it's equivalent to this form, a over x plus 1 plus b over x minus 2. So that's taken from that first set of standard partial fractions. The function of x, so here's the function of x here, the function of x over x plus a times x plus b equates to a over x plus a plus b over x plus b. Well, we know what a and b are. A is one there. Don't forget small letters and big letters. So we can quite happily say then that this compound fraction is made up of these separate parts. Okay. Now, if you think about it, when we looked at adding fractions, because this is what we're going to do here, we've got two fractions here, a fraction there and a fraction there. If we add them together, the first thing we do is make a common denominator, and that's simply done by multiplying these together. Well, that's what we've done here then, haven't we? We've actually made the common denominator. So I hope you can see somehow that this is actually quite valid. What we have to do now, of course, is work out the values for A and B. These are constants. And the process is quite straightforward. So if you follow the process, you'll see exactly how it works and be able to cope with it. Okay. So the first thing we do is multiply both sides, that's both sides of this equate sign, by this denominator on the left hand side. So I'll just make a little note there. Multiply both sides by the denominator on the left hand side. So let's do it. We've got, a bit smaller perhaps, 8x minus 7 over x plus 1 times x minus 2 times x plus 1 times x minus 2 equates to a over x plus 1 times x plus 1 times x minus 2 plus b over x minus 2 times x plus 1 times x minus 2. And really, because we've multiplied everything by x plus 1 times x, we've not changed the expression, we just made it so much bigger. But now I'm hoping you can see what actually happens. And I'll just change my pen colour, so I'm hoping you can see that that and that will cancel with that and that, and that will cancel with that, and that will cancel with that. And if we do that, you can see then we're left with what I think is an easier expression. Therefore, we're left with just 8x minus 7 equates to a into x minus 2 plus b into x plus 1. Okay, so I hope you can see that process. Nothing really too strange, I hope. Now then, what we've got here is an expression with two unknowns, and you can't solve an expression with two unknowns. We've got capital A and capital B. These are two unknowns. And what we've got to do is get rid of one of the unknowns. If you get rid of one of the unknowns, they've only got one left, and you should be able to solve an expression for one unknown. Well, the easiest way, of course, is to make this not a times x minus 2, but a times nothing. And if you've got a times nothing, then that'll disappear, won't it? So now we've got to decide a value of x that'll make this bracket into nothing. And I hope you can see that if we let x equal 2, 2 minus 2 is nothing, and therefore it will disappear. So that's it. It might seem complicated at first to begin with, but once you go through one or two of these, I think you'll find that it's not really, it's quite a simple process, and you should be able to cope with it. So like I say, what we're going to do, we're going to choose a value of x to get rid of one of the expressions. Choose a value of x to let one of the brackets equal 0. So let's just put that here. Choose a value of x. And don't forget, x can be any value you like, because it is a variable. To make one of the brackets equal 0. Okay, so what I'm going to do then, I'm going to get rid of a by letting x equal 2. So let x equal 2. And therefore we have 8 times x, but x is 2, minus 7 equates to a into 2 minus 2 plus b into 2 plus 1. And wherever we see x, we let it equal 2, change it to 2. Well, this is 16 minus 7s, so therefore 16 minus 7 equates to a times nothing plus b times 3. And you can see then that the a will disappear. So here we've got 9 equals 3b, and therefore 9 divided by 3 equals 3b divided by 3, and therefore 3 equals b, or rather b equals 3. That's okay. Now we're going to determine the value for a, and all we've got to do is make this bracket 0. I mean, we could do it another way as well, but it's simpler to say let x equal minus 1, therefore b disappears. Okay. So now let x equal minus 1 to get rid of the b term, and so solve for a. Okay, so again what we're doing is in this expression here we're letting the value of x equal minus 1. Okay, so we have 8 times minus 1, therefore 8 times minus 1 minus 7 equates into a into minus 1 minus 2. Let's just check, because we've got a into x minus 2, yes, plus b into minus 1 plus 1. So you got minus 8 minus 7 equates to a into minus 3 plus b into nothing. Therefore minus 15 equals minus 3a, and I'm sure as you can follow, therefore minus 15 divided by minus 3 equals minus 3a divided by minus 3, and therefore a equals 5. Okay, so we've gone through the process to determine the value of these two constants, a and b. So we've got a equals 5 and b equals 3. So putting these back into the partial fractions, we have 8x minus 7 over x plus 1 times x minus 2. Now it equals, now can we know the value of a? 5 over x plus 1, and we know the value of b, 3 over x minus 2. So that's why it's gone from the equates sign to the equal sign, because we've worked out the values for a and b. But we can check by adding these two fractions together, and we should come back to this. So check by adding the two fractions. Now I think you'll see why it's important to be able to add fractions. 5 over x plus 1 plus 3 over x minus 2. Well, the common denominator is just simply multiplied together. X plus 1 times x minus 2. Now, because we changed this denominator, we must change the numerator. Cover that up, multiply the 5 by the x minus 2. So it's 5 times x minus 2 plus the 3 times the x plus 1. Like I say, it's a very simple process to add fractions. Now you can't do this on your calculator, but because you know how to add fractions from a previous lesson, you can carry on with this. So it equals 5x minus 10, expanding that bracket, 5 times the x, so 5 times the minus 2, plus 3x plus 3. We don't have to bother with that, but we could do, but I'll leave it like that for now. X plus 1 times x minus 2. If you collect the like terms, you've got 5x and 3x, that's 8x. So it equals 8x. Minus 10 plus 3 is minus 7 over x plus 1 times x minus 2. And we've checked our answer, and we now know it's right. So there's one simple example, I think, of going through partial fractions. Of course, just to complete the scenario, we said that this integration is more difficult to do, but now we can rewrite that compound fraction, and therefore rewrite the integral. Okay, in this way. Therefore, I equals the integral between 0 and 6 of 5 over x plus 1 plus 3 over x minus 2 dx. Well, as you'll find out, integration is a summing action, and to me there are two separate integrals which we can bring together. We'll do this, like I say, further, but I'm just trying to justify why we do partial fractions. So because integration is a summing action, that is exactly the same as the line above. And of course, that's the same of our original integration. So there, I hope you can see why we do integration by parts, or partial fractions, why we do partial fractions. Integration by parts is something completely different. And how the process goes for a simple compound fraction, as I've just shown you. We'll go through another one in the next video, in fact a couple more in the next video, and some more complicated ones further on. So thank you for watching me, and I hope to see you in the next video.